Okay, hi everyone, and welcome to my poster, Facilitating Joint Spatial Planning for Imperiled Species and Coastal Resiliency with Habitat Models and Social Data. The imperiled species we're talking about in this case study that we present are the salt marsh dependent birds in coastal United States that are dependent on these low-lying salt marshes that you see in this picture here, and are threatened by sea level rise because it impacts their nesting survival. So the black rail here has recently been listed on the Federal Endangered Species List. And we think that imperiled species like these that are threatened by sea level rise should really be placed on the map alongside of other social concerns and physical factors that are currently used in spatial sea level rise planning. So a quick overview of how sea level rise can impact such low-lying coastal species, of which there are many around the world. So it's not just a New Jersey problem. But of course, sea level rise can directly impact habitats and disturbance regimes as they do for the salt marsh dependent black rail. They can also influence human activities in terms of resiliency actions like shoreline armoring or creation of new living habitats. So indirect effects through impacts to human communities could be just as severe as sea level rise. So in any case, those two things are going to increasingly overlap as sea level rise progresses, and we're going to need to integrate planning, spatial planning for those two aspects. So how do we put imperiled species on the map for coastal sea level rise planning, and how do we integrate this information with social factors that also influence the ability to not just restore endangered species habitat, but also protect human communities? So we do this with Bayesian habitat models, and we build that using survey data collected by the New Jersey Endangered Species Program, a lot of environmental variables about wetland cover types, and produce a suitability map that I'll show you in a minute that predicts either, on a continuous scale, either high or low suitability for that species. So here are some examples of spatial covariance. We use different marsh layers. This is the percentage of high marsh habitat in a region. And we basically build a statistical model that forms the background for this map I'm going to show you next, which is where the real integration couldn't happen with habitat models and resiliency planning. So this is a species distribution model projected from the statistical model I just showed you, and it basically shows areas of New Jersey salt marshes that are either from almost 0% suitable or likelihood of finding a black rail to more than 1 in 4 chance, say. And I think it's pretty clear that using maps like this can really aid even on the project-specific scale. So if you're going to be working on a resiliency project in the Great Egg Harbor estuary, for example, you'd really want to know that black rail are highly likely to occur and where within that estuary they are. That is not necessarily a new concept for species distribution models, although it hasn't really been implemented with sea level rise planning thus far. You can also present uncertainty estimates, which is an advantage of our Bayesian workflow. So you would not only know where rails are highly likely to occur, but where we might be most uncertain about that kind of information. So that could weight your decision-making process, and in any case is more transparent than many times is implemented. So the final factor we wanted to do was take that distribution information and use social data, basically ownership data and tax parcel data, to really characterize what was going on in this rail habitat and would influence not only the ability to restore habitat, but also to perform actions to protect human communities from sea level rise. So the white stuff you see here is actually the private land, and we're going to focus on that in terms of summarizing what's going on with the rail habitat. We found that about 25% of rail habitat is on private land, so this green dot you see, and the rest is on public land of various sorts. Taking that private land and taking a closer look at it, and it's the green dot you should be paying attention to because that's our final model. About 5,000 individually owned parcels are what characterize that information. So what we did is really take a deep dive into what those 5,000 parcels were, and we characterized the owners as living where they lived in relation to the parcel, how large those parcels were, which would affect how many you need to buy, I guess, and also what proportion of marsh they were, and the range of costs, which really might be the ultimate metric affecting how easy it is to deal with these private landowners. That ranged from hundreds of millions of dollars in the middle of Atlantic City to less than $1,000. So we hope that this approach just kind of better informs and takes one more step towards putting those species on the map and allowing us to integrate them into sea level rise planning. And here you see a salt marsh that is prime black rail habitat in the Tuckahoe River watershed.